Morning students, today we are going to discuss the 2017 NEET question paper physics, and the code of this question paper which I am going to discuss is B, and from question number 136 onwards the physics starts. So the two astronauts are floating in gravitational free space after having lost contact with a spaceship. The two options are given as move towards each other, move away from each other, will become stationary, keep floating at the same distance between them. So, due to the gravitational force of attraction, we move towards each other. So, the option is the first one. Question number 137. This is a question related to the Young's double slit experiment. Young's double slit experiment is first performed in air and then in a medium other than air. It is found that 8th bright fringe in the medium lies where 5th dark fringe lies in air. The refractive index of the medium is near. So, the 8th bright fringe, in the medium. So, why 8th bright fringe? And in the medium lies where 5th dark fringe lies in air. So why 5th dark fringe and lies in air? So the fringe positions are given by 8 d lambda by d, and it is in medium, so the fringe width decreases by mu, that is equal to 2 into 5 minus 1 into d lambda by 2d. Here d lambda by d lambda by d gets cancelled. Mu is given by 16 by 9, that is equal to 1.69, will be 1.69. Option corresponding to this one will be second option. So question number 138 is a question related to the transistors. In a common emitter transistor, the audio signal voltage across the collector is 3 volt. The resistance of the collector is 3 kilo ohm. If the current gain is 100 and the base resistance is 2 kilo ohm, the voltage and power gain of the amplifier is. So the voltage gain AV is given by beta times of RC by RB. So that is equal to, the beta value is given to be 100 and the RC value is given to be 3 kilo ohm, 3 into 10 to the power 3, and RB value is given to be 2 kilo ohm, that is 2 into 10 power 3. So 10 power 3 gets cancelled and it is 257. So the voltage gain is equal to 150 and the power gain is given to be beta square into RC by RB, that is equal to 100 into 100 into 3 into 10 power 3 by 2 into 10 power 3, that is 10 power 3 gets cancelled and it is 250. So it is 53 is 150, 150 into 100, that is 15,000. So the voltage gain is given to be 150 and the power gain is given to be 15,000. So the option corresponding to this question is second option. Question number 139. The question is related to the force between two wires carrying current. An arrangement of 3 parallel straight wires placed perpendicular to plane of paper carrying same current I along the same direction is shown. Magnitude of force per unit length on the middle wire is given by. So, magnitude of force per unit length, it is given to be small f is equal to mu naught I1 I2 by 2 pi d. Now here all these conductors carry current in the same direction and their outward as their currents, like currents attract each other. So force on B by C will be in this direction and force on B by A will be in this direction. So FBC is equal to mu naught I square by 2 pi d, and force on B by A is equal to mu naught I square by 2 pi d. So the net force on B per unit the length is given by root 2 times of force on B by C, as these two forces are equal and perpendicular to each other. So the force on B is given by mu naught I square by root 2 pi d. So the correct answer is mu naught I square by root pi d. The option corresponding to this answer is third option. Question number 140. This question is related to de Broglie wavelength. So the question is, the de Broglie wavelength of a neutron in thermal equilibrium with heavy water at a temperature T and mass m is given. So we know that the de Broglie wavelength is given by lambda is equal to h by mv. In terms of kinetic energy, it will be 2m k, where k is the kinetic energy and m is the mass of neutron, and k is equal to 2m into 3 by 2 kb into t. So here 2 gets cancelled and lambda is given by h by 3m kb into t under 2. So this is the de Broglie wavelength of a neutron which is in thermal equilibrium with heavy water at a temperature T. So the answer is h by root of 3m kbt. So the option corresponding to it is the first one. So, question number 141. This question is related to the decay law. Radioactive material A has decay constant 8 lambda and material B has decay constant lambda. Initially they have same number of nuclei. After what time the ratio of number of nuclei of material B to that of A will be 1 by E. So we know that from the decay law n is equal to n naught into e power minus lambda, where n is the number of nuclei present at that time and n naught is the initial number of nuclei. So they have given the condition that initially both have the same number of nuclei initially. After what time the ratio of number of nuclei of material B to that of A will be 1 by E. So Na is equal to n naught A into e power minus 8 lambda t, and Nb is equal to n naught B e power minus lambda t. Now Nb by Na is equal to n naught B by n naught a into e power minus 8 lambda t by e power minus lambda t. So the given condition is that both have initially the same number of nuclei. So these two gets cancelled, and this is equal to e power minus 7 lambda t. Now nb by na. So he has given that nb by na is equal to 1 by e is equal to e power minus 7 lambda t, implies 7 lambda t is equal to 1, implies t is equal to 1 by 7 lambda. So the option corresponding to this answer is first option related to logic gates. So 142. So here this is a NOR gate and this is also a NOR gate, whereas this is a NOT gate. The output of NOR gate is Y1, whereas the output of this NOR gate is Y2. So Y1 is equal to A or B complement, Y2 is equal to Y1 or Y1 complement, that is equal to Y1 complement, that is equal to A or B whole complement, Y1 that is again complement, that is again A or B. Now Y is equal to Y2 complement, that is equal to A or B complement. So this gate represents a NOR gate. The option is 2 is correct. Good morning students. This question number 143 is a question from current electricity. So the resistance of a wire is R ohm. If it is melted and stretched to n times its original length, its new resistance will be. So the mass before stretching and after stretching remains the same. So volume before and density before, because mass equal volume into density, and volume after and density after. Now density is constant, so volume is also constant, that is area into length equal to constant. We know that R is equal to rho L by A. Multiplying by A, it is rho V by A square. Multiplying by L, that is equal to rho L by rho L square by B. So R is proportional to L square. So as the wire is melted and stretched to n times its original length, its new resistance will become n square R. So the second option is the. So this is a question related to Doppler effect. Question number 144. Two cars moving in opposite directions approach each other with speed of 22 meter per second and 16.5 meter per second respectively. The driver of the first car blows a horn having a frequency 400 Hz. The frequency heard by the driver of the second car is. So the first car is moving with a speed of 22 meter per second, and the second car is also moving towards the first car, that is moving with a speed of 16.5 meter per second. The driver of the first car blows a horn of 400 Hz. The frequency heard by the driver of the second car is. So the frequency heard by the driver of the second car. So the second car is driver is the listener and the source of sound is the first car, and the velocity of sound is 340 per meter per second. So we know the apparent frequency heard by the listener is given by V plus or minus VL by V plus or minus V source into frequency of the So now here whether to apply plus or minus, as the listener, as the source is approaching the listener, definitely the frequency of sound heard by the listener increases. So if it is plus, then FM increases. So V plus VL, and the source is approaching the listener, again the frequency is increasing. So definitely FL should increase, means the denominator should decrease. Accordingly, V minus Vs into Fs. So the velocity of sound already is given to be 340, and the velocity of the listener is 16.5, and the velocity of sound, that is V, is again 340, and velocity of the source is 22, and the frequency of the source is 340. And after substituting all these values, we are going to get it as 448 Hertz. So the option corresponding to this answer is third. This is a question related to electromagnetic waves. In an electromagnetic wave in free space, the root mean square value of the electric field is 6 volt per meter. The peak value of the magnetic field is. So we know that E naught by B naught is equal to C. Also, E naught is equal to root 2 times of ERMS. So implies B naught is equal to root 2 times of ERMS by C. Substituting these values, you are going to get 2.83 into 10 power minus 8 Tesla. So the option 1 is the correct answer. So this is a question from heat conduction. Question number 146. Two rods AB of different materials are welded together as shown in figure. Their thermal conductivities are K1 and K2. The thermal conductivity of the composite rod will be. So, two thermal resistors are connected in parallel. So, the equivalent thermal resistance is given by 1 by R1 plus 1 by R2. And thermal resistance is given by L by Ka. So R is equal to, the thermal resistance is given by L by Ka. So 1 by R equivalent is equal to K1 A by D. Okay. It should be K equivalent, that's what we have to found. So Ka by D, that is equal to K1, and the area is A by 2 by D plus K2 into A by 2 by D. So K is equal to K1 plus K2 by 2. So the option corresponding to this one will be the fourth. This is a question from semiconductor tables. Question number 1%. Which one of the following represents forward bias? So the P should be at a higher potential corresponding to Q. That means Vp is greater than Vq. So Vp minus Vq should be greater than 0. So minus 4 minus of minus 3, that is equal to minus 1 volt, which is less than 0. This one minus 2 minus 2 minus 4 volt, that is also less than 0. And the third one will be 3 minus 5 minus 2 volt, that is also less than 0. Whereas fourth one is 2 volt, that is greater than 0. So the fourth option is the correct answer of this question. This is a question related to magnetism. A 250 ton rectangular coil of length 2.1 centimeter and width 1.25 centimeter carries a current of 85 microampere and subjected to a magnetic field of like 0.85 Tesla. The work done for rotating the coil by 180 degrees against the torque is. So we know that work done is equal to mv into cos theta 1 minus cos theta 2, where m is the magnetic moment that is given by I into A, and B is the magnetic field 0.85 Tesla. So m is equal to I into A, that is equal to current is given to 85 microampere, 85 into 10 power minus 6, and the area of the coil is 2.1 into 1.25 into 10 power minus 4, and B is given to 0.85 Tesla, and theta 1 is equal to 0 degrees, and theta 2 is equal to 180 degrees. Substituting all these values in the above equation, the work done turns out to be 9.1 micrometer. So the option corresponding to this will be. This question is from Earth's magnetism. If theta 1 and theta 2 be the apparent angles of dip observed in two vertical planes at right angles to each other, then the true angle of dip is given by tan theta 1 is equal to tan theta by cos alpha, and tan theta 2 is equal to tan theta by cos of 90 minus alpha, that is enough. We know that sin square alpha plus cos square alpha is equal to 1. So sin alpha is equal to tan square theta cot square theta 2 plus cot square theta 1 is equal to 1. So cot square theta 2 plus cot square theta 1 is equal to cot square theta. So the correct answer will be 4. This is a question related to potentiometer. A potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves option 1 potential gradients, option 2 a condition of no current flow to the galvanometer, option 3 a combination of cells, galvanometer and resistances, option 4 cells. So the correct option is no current flows through the galvanometer. That is the option 2 is the correct answer for this question. This question is related to resolving powers. So the ratio resolving powers of an optical microscope for two wavelengths lambda 1 and lambda 2 is, we know that the resolving powers are inversely proportional to wavelengths. So R1 by R2 is equal to lambda 2 by lambda 1, that is equal to 6000 by 6000 angstrom by 4000 angstrom, and R1 is 2, R2 is equal to 3 is to 2. So the option corresponding to this question is second. Problem from prism, question number 152. A thin prism having refracting angle 10 degrees is made of glass of refractive index 1.42. This prism is combined with another thin prism of glass of refractive index 1.7. This combination produces a dispersion without deviation. The refracting angle of second prism should be. So the condition for dispersion without deviation is A dash by A is equal to mu dash minus 1 by mu minus 1. Substituting, we have to find A dash, substituting the value of A as 10 degrees and mu dash as 1.7 minus 1 by 1.42 minus 1. The A dash value is 5.83, approximately I can take it as 60. So the answer would be related to the resistance question. So the resistance of wire is R ohm. If it is melted and stretched to n times its original length, its new resistance will be. So mass of the wire will remain constant. So mass equal to volume into density is equal to constant. So as density won't change, so the volume remains constant. So the resistance of the wire is given by R equal to rho L by A, multiplying by length rho L square by volume, because area into length is equal to volume, and multiplying by area, it is rho V by A square. So in this case, R is proportional to L square. Let us we take these two formulae. This one, R equal to rho L square by V, because rho is resistivity of the material. It is a property related to the material, so it is constant. Volume is constant. R is proportional to L square. So as length is stretched n times, the new resistance will become n square times. So the option corresponding to it will be n square R. There is a problem related to relative velocity. Question number 154. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in T1. On other days, it is a stationary escalator. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time T2. The time, so in T2, remains stationary. The time taken by her to walk on the moving escalator will be. Now in all these cases, the displacement is same. So let the displacement of Preeti be N. Then she walked up the stationary escalator in time T1. So velocity of the Preeti with respect to the escalator is equal to, if L is the displacement of Preeti, then L by T1. On other days, if she remains stationary on the moving escalator, that is the velocity of the escalator is equal to L by T2. Now the time taken by her to walk up on the moving escalator will be, that is, the velocity of the Preeti is equal to how much? So we know that velocity of the Preeti with respect to the escalator is equal to velocity of the Preeti with respect to the ground minus velocity of the escalator with respect to the ground. So velocity of the Preeti is equal to, with respect to the ground, is equal to velocity of the Preeti with respect to the escalator plus velocity of the escalator with respect to the ground. So velocity of Preeti is equal to, velocity of Preeti is equal to velocity of the Preeti with respect to the escalator L by T1 plus velocity of the escalator with respect to ground L by T2. Velocity of the Preeti, velocity of Preeti is equal to L by T, that is equal to L by T1 plus L by T2. So time T is equal to T1 T2 by T1 plus T2. So this is what the question has been asked. So time T is equal to T1 T2 by T1 plus T2. So the option corresponding to this one is option number 2. This is a question from thermodynamics. Question number 155. Thermodynamics processes are indicated in the figure. So the first process is the volume is constant. As volume is constant, it is an isochoric process. So it is an isochoric process. And the volume and the process 2 is an adiabatic process. So it is A. And the process 3 is an isothermal process because temperature is constant, so isothermal, so D. And process 4 pressure is constant, isobaric, CADB. So option corresponding to this is the first option. Question related to the circular motion. Question number 156. One end of string of length L is connected to a particle of mass m and the other end is connected to a small peg on a horizontal table. So this is the peg to which it is connected, and a wire of length L, it is rotated, moves in a circle with a speed v. Like this it is rotating. So definitely I can say that as it is moving in a circular path, a centripetal force must act and the tension in the string provides the necessary centripetal force. So the net force on the particle is T. That is the option. Question from related to closed organ pipes. The two nearest frequencies of a tube closed at one end and open at other end are 220 Hz and 260 Hz. What is the fundamental frequency of the system? So we know that the frequencies in a closed organ pipe are given by 2n minus 1 into V by 4L. So they're closed. So Fn plus 1 is equal to 2 into n plus 1 minus 1 into V by 4L. So Fn plus 1 minus Fn is equal to 2 into n plus 1 minus 1 minus of 2n minus 1 into V by 4L, that is equal to 2n plus 2 minus 1 minus 2n plus 1 into V by 4L. So minus 2n plus 2n minus 1 plus L gets cancelled. So that is equal to V by 2L, V by 2L, Fn plus 1 minus Fn. These values are given to be 220 Hz and 260 Hz. So V by 2L is equal to 40 Hz. And fundamental frequency. Substituting n equal to 1 in this equation, F1 is equal to 2 into 1 minus 1 into V by 4L. So that is 2 minus 1, 1 V by 4L. V by 4L. But we know V by 2L, that's half of V by 2L, that is half of V by 2L. So that is equal to 20 Hertz. So the fundamental frequency is given by 20 Hertz. First option. Related to photoelectric effect. The photoelectric threshold wavelength of silver is 3250 into 10 power minus 10 meter. The velocity of the electron ejected from a silver surface by ultraviolet light of wavelength 2536 into 10 power minus 10 meter is. So we know the Einstein's photoelectric equation is K max is equal to HF minus W that is can written as hc into 1 by lambda minus lambda th, where lambda is the wavelength of the incident light and lambda th is the threshold wavelength, and k max can be written as half m v max squared. Substituting all these values, v max comes out to be 6 into 10 power 5 meter per second. So this is a problem from electricity. Question number 159. The figure shows a circuit that contains three identical resistors with resistance 9 ohm each, and inductors which are identical having 2 millihenry, and an ideal battery is connected 18 volt, and current I passes through the battery. What is the current I that passes? What is I? Current I through the battery just after the switch is closed. So just after the switch is closed, L behaves, that is the inductor behaves like an open circuit, and capacitor behaves like a short circuit. So taking into these considerations, let us redraw the circuit. Soon after it is closed, the battery it is, inductor open circuit, resistor, and then another resistor, and here another resistor, whereas inductor will act like an open circuit and a capacitor like a short circuit. So this is E, this is R, and this is R. Soon after the switch is closed, current I flows those three resistors, these two resistors. So the equivalent resistance is R by 2 as they are connected in parallel. I into R by 2, that gives you the E. So solving this, the value of I tends to be 4 ampere. As there is no option, there is one option from heat radiation. And this question number 160, a spherical black body with a radius of 12 centimeter, radius 450 watt power at 500 Kelvin. If the radius were halved and the temperature doubled, the power radiated in watt would be. So from Stephen's law, power is given by sigma A T power 4 for a black body, and P is proportional to is A into T power 4. As it is a spherical body, the surface area is given by 4 pi r square T power 4. So P2 by P1 is equal to R2 by R1 into whole square into T2 by T1 whole power 4. So R2 is, the radius is half, and the temperature is, temperature here doubled and the radius was half. So temperature doubled, 2 T1 by T1 whole power 4. R1 gets cancelled, T1 gets cancelled. So P2 by P1 is equal to 1 by 4, 2 square, and 2 power 4 is 16, 4 fours. So P2 is equal to 4 times of P1, that is equal to 4 into P1 is 450 watt, that is equal to 1800 watt. So the correct option is third. 161 question. This is a question from rotational motion. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 cm. What is the angular acceleration of cylinder if the rope is pulled with a force of 30 Newton? So this is a hollow cylinder. It is pulled with a force of 30 Newton, whose radius is given by 40 into 10 power minus 2 meter. Mass is 3 kg. We know that tau is equal to I alpha. So alpha is equal to tau by I. Tau is given by radius r into force F, and I is given by mr square. So m1r square gets cancelled. upon substituting the value of force mass, we are going to get it as 25 radian per second square. The option corresponding to this will be the second one. Question number 162. This is a question related to the conservation of angular momentum. Two disks the same moment of inertia rotating about their regular axis passing through center and perpendicular to the plane of disk with angular velocities omega 1 and omega 2. They are brought into contact face to face, coinciding the axis of rotation. The expression for loss of energy during this process is. So the loss of energy is given by half I1 I2 by I1 plus I2 into omega 1 minus omega 2 whole square. Assuming that both the disks are initially moving in the same direction, and here they have the same moment of inertia, so I1 is equal to I2 is equal to I. Substituting in this, the expression daily turns out to be 1/4 of I into omega 1 minus omega 2 square. So the option corresponding to this will be the first. This is related to equipartition theorem. A gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. Neglecting all vibrational modes, the total internal energy of the system is U is equal to F by 2 into N into RT. So U is equal to oxygen is a diatomic gas having degrees of freedom 5 by 2. N is the number of moles, that is 2 into RT plus 4 moles of argon. Argon is a monoatomic gas, so it has a degrees of freedom 3 and number of moles are 4 into RT. So it is 2 2s are, this is 2. So 5 plus 6, U is equal to 11 RT. So the option is third one. Question number 164. This question is related to mechanical properties of solids. The bulk modulus of a spherical object is B. If it is subjected to uniform pressure P, the fractional decrease in radius is. So we know that the bulk modulus is given by B is equal to del P by del V by V minus. So as it is a spherical object, volume B is given by volume of that is given by 4 by 3 pi r cube, where r is the radius of the spherical object. So the fractional decrease in volume is given by 3 into del r by r. So substituting this value here, del V by V is equal to del V by V equal to del P by V minus, that is equal, that implies 3 del R by R is equal to minus change in pressure is P by V. So del R by R is equal to minus P by 3V. So this is the fractional decrease in radius, that is P by 3V. So the option corresponding to this will be the. So this is a question related given from the system of particles in rotational motion. Which of the following statements are correct? Center of mass of a body always coincides with the gravity of the body. Center of mass It is not necessary that it should always coincide. Center of mass is the point about which the whole mass is supposed to be concentrated and external force acts at that point. Whereas the center of gravity of the body is the point about which the gravitational torque will be zero. So this is not always, maybe. Center of mass of body is the point at which the total gravitational torque on the body is zero. Yes. So it is the point about which if a force acts on the center of mass, it produces linear, translational motion, but not rotational motion. So this is correct. A couple on a body produces both translational and rotational motion in a body. No, a couple always produces rotational motion. So this option is also wrong. The fourth option, mechanical advantage greater than 1 means small effort can be used to lift a large load. Mechanical advantage is equal to effort by load. So if it is greater than, then effort is greater than load means definitely small effort can be used to lift a large load. So this is also correct. So this is the correct answer. Question number 166. This is a problem from related to gravitation. The acceleration due to gravity at a height h equal to 1 kilometer above the earth is same as at a depth d below the surface of the earth. Then, so g at an altitude is equal to g at a depth d, that is g as h is much less than radius of r. So g into 1 minus 2h by r is equal to g into 1 minus d by r. So 2h is equal to d, then d is equal to, h is 1 kilometer, so depth is equal to 2 kilometer. So the option corresponding to this will be the third. Question number 167. This is a question related to Newton's laws of motion. So, question. Two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible spring. The whole system is suspended by a massless spring as shown in figure. The magnitudes of acceleration of A and B immediately after the string is cut are respectively. So before cutting mass B, so here there is only one interaction here, that is the tension T upward. The tension T is acting upward and the weight of the, and its mass is given as m, the weight acts downwards. So T is equal to mg for block B, and for block A, three m. So there are two interactions. So this is being pulled by the spring Fs and tension T, and also the weight 3 mg. So Fs is equal to 4 mg. After cutting, so here it has been cut. There is no change in the spring force, but the tension in the string becomes 0. So this is block B, having mass and only one force that acts that is downward. Therefore, acceleration of the block B is g and acceleration of block A. So here this is the block A having mass 3m, only spring force acts, there is no tension. So here it is only interacts. So I can say that Fs minus 3mg is equal to 3m into acceleration of A. So acceleration of A is equal to 4mg by 3m, that is nothing but g by 3, and it is upward and it is downward direction. So the options corresponding to it will be g by 3 comma g. The number 168. This is a question from the Bohr's theory. The ratio of the wavelengths of the last line of Balmer series and the last line of Lyman series. We know the Rydberg's formula is 1 by lambda is equal to rz square into 1 by n 1 square minus 1 by n2 square. So they said last line. So for Balmer series, n1 is equal to 2 and n2 is equal to infinity. So 1 by lambda Balmer is equal to rz square into 1 by 2 square minus 1 by infinity. For Lyman series, 1 by Lyman series n1 is equal to 1 and n2 is equal to infinity. So 1 by lambda L is equal to rz square into 1 by 1 square minus 1 by infinity. So 1 by lambda L by 1 by lambda Balmer is equal to lambda Balmer by lambda Lyman is equal to this value is r by 4 and its value is equal to r by 1. So it will be 4 by 1. So the correct answer, the option for this is second one. 69. This is a question related to rotation of the plane mirror. A beam of light from a source L is incident normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back as a spot on a scale placed just above the source L. When the mirror is rotated through a small angle theta, the spot of the light is found to move through a distance y on the scale. The angle theta is given. So, a beam of light from a source L is incident normally on a so this is a plane mirror. Now it is incident normally at a distance x. The beam is reflected back as a spot on the scale, so almost we can take it to be reflected back. Now when the mirror is rotated by small angle theta, so when it is rotated by small angle theta, then we know that the reflected ray rotates by an angle 2 theta. So the reflected ray rotates by an angle 2 theta. The spot of the light is found to move per distance y on this scale. So it has moved here y. The angle theta is given. So tan 2 theta is equal to y by x. As they said, small angle. So I can say 2 theta is equal to y by x and theta is equal to y by 2x. So the answer corresponding, the option corresponding to this answer is 4. Force constant K is cut into lengths of ratio 1 is to 2 is to 3. They are connected in series and the new force constant is K dash. Then they are connected in parallel and force constant is K double prime. Then K dash is to K double dash. So this is a problem related to springs. Now we know that K is proportional to 1 by L, that is K1 L1 is equal to K2 L2 is equal to K3 L3 is equal to K into L, where L is the length of the spring, say then L1 is equal to L by 6 and L2 is equal to L by 3 and L3 is equal to L by 2. Implies K1 is equal to 6K, K2 is equal to 3K and K3 is equal to 2K. So first they are connected in series. So in series the equivalent new constant is K prime. So K prime is equal to K, because when they are connected in series it becomes the original spring, so K dash is equal to K. When they are connected in parallel the force constant is K double prime. So K double prime is equal to K1 plus K2 plus K3, that is equal to 11K. So they are asking K dash is to K double dash, that is equal to 1 is to 11. The option corresponding to this is the second one. Problem from electrostatics. Question number 171. The diagrams below show regions of equipotentials. A positive charge is moved from A to B in each diagram. We have to find out the work done in various. We know that the work done is equal to Q del V. And the value of del V in all these cases, that is from A to B, is same. The work done in all the cases is same. In all the 4 cases, the work done is the same. So the option is 172. Question number 172. Suppose the charge of a proton and an electron differ slightly. One of them is minus E and the other is E plus del. If the net of electrostatic force and gravitational force between two hydrogen atoms placed at a distance d much greater than atomic size apart is 0, then del E is of the order of. Now, the net charge on hydrogen is equal to E plus del E minus E, that is equal to del E. And he has given that electrostatic force is equal to the gravitational force. So K into del E whole square by d square is equal to Fg, that is G mh square by d square. Substituting all the values in this equation, the del E will have the value of 2.6 into 10 to the power minus 37 Coulomb. So it has an order of 10 to the power minus 37. Number 173 is the question. from dimensional analysis. A physical quantity of the dimensions of length that can be formed out of C, G and E square by 4 pi epsilon naught is. So the dimensions of L is equal to C power A, G power B and E square by 4 pi epsilon naught power C. So the dimensions of C is LT power minus 1 and dimensions of G, that is M power minus 1, L power 3, T power minus 2, B, and the dimensions of E square by 4 pi epsilon naught, that is ML cube T power minus 2 power C. So M power minus B plus C, L power A plus 3B plus 3C and T power minus A minus 2B minus 2C. So equating the powers on both sides, minus B plus C is equal to 0, A plus 3B plus 3C is equal to 1, and then minus A minus 2B minus 2C, that is equal to 0. Solving these equations we get A is equal to minus 2 and B is equal to C is equal to half. So the dimensional formula of L can be written as 1 by C square into G into E square by 4 pi epsilon naught whole power half. So this is the answer. The option will be the sixth. Question number 174 is a question from polarization. Two polarized P1 and P2 are placed with their axis perpendicular to each other. Unpolarized light I0 is incident on P1. A third polarizer P3 is kept in between P1 and P2 such that its axis makes an angle of 45 degrees with that of P1. The intensity of transmitted light is. So the intensity of transmitted light through a polarizer is given by, from Malus law, that is given by I is equal to I0 cos square theta. Now here, first is the first polarizer P1 onto which unpolarized light of intensity I0 is incident, then I'll get I0 by 2. Now this light is incident on second polarizer, which is placed at an angle of, that is the third polarizer, as I said it is third polarizer, it is kept at an angle of 45 degrees. Now I0 by 2 is incident on the third polarizer, which is at an angle of 45 degrees with respect to the path axis of P1, that is polarizer 1. Then the intensity of the transmitted light will be I0 by 2 cos square 45, that is equal to I0 by cos square 45 1 by root 2 whole square, that is cos 45 1 by root 2 whole square, 1 by 2 into 2 1 by 4. Now this is incident again on second polarizer. This is P2, which is at an angle of 45 degrees with the path axis of P3. So now the intensity of the transmitted light will be I0 by 4 cos square 45. So that is equal to I0 by 8. So the correct option will be second. This is a problem from simple harmonic motion. A particle executes linear SHM with an amplitude of 3 cm. When the particle is at 2 cm from the mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in seconds is. So according to the problem, V is equal to A and the velocity is given by in terms of amplitude and position is given by omega into root of a square minus x square, whereas acceleration is given by omega square x. Now 1 omega gets cancelled here and this omega can be written as 2 pi by t into x. Substituting the value of amplitude as 3 centimeter and the position of the particle as 2 centimeter, the value of t turns out to be 4 pi by root 5 second. So the option corresponding to this will be the second. Question is from fluid mechanics. A tube with both ends open to the atmosphere is partially filled with water. Oil which is immiscible with water is poured into one side until it stands at a distance of 10 mm above the water level on the other side. Meanwhile, the water rises by 65 mm from its original level. The density of oil is. So the pressure at B and the pressure at C are same. So pressure at B is equal to pressure at C. So the pressure at B is given by P atmosphere plus density of oil, height of the oil G is equal to P atmosphere plus density of water, height of water into G. Then P atmosphere gets cancelled, G gets cancelled. I want the density of the oil. So density of the oil is equal to density of the water, height of the water, height of the oil. So density of water is given by 1000 and height of the water column is 65 and 65, that will be 130 into 10 power minus 3 meter. Height of the oil column is 140 into 10 power minus 3 meter. Upon solving this, you are going to get it as approximately 928 kg per meter cube. So the correct option is third. This is the problem from work energy power. Consider a drop of rain water having mass 1 gram, that is 10 power minus 3 kilogram, falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take G constant with a value of 10 meter per second square. The work done by the gravitational force. Work done by the gravitational force equal to mg into hi minus h final. Taking this one as h equal to 0 level, that is a reference level, hi is equal to 0 and this hf is equal to minus 10 power minus 3 meter. Then substituting the values mass as 10 power minus 3, g as 10 and minus of minus plus, it is 10 power 3, that is equal to 10 joule. Applying work energy theorem, work done by all forces, that is gravitational force and resistive force equal to change in kinetic energy, K final minus K initial. Now K initial is equal to 0 and work done by gravity, already we know it is 10 joule. So work done by the resistive force is equal to, the final kinetic energy is half mvf square minus 10. Solving this, we are going to get it as minus 8.75 joule. So this is the work done by the resistive force and this is the work done by the gravitational force. So the correct answer related is third. This is a problem related to motion in a plane. Question number 178. The x and y coordinates of the particle at any time are given by x is equal to 5t minus 2t square and y is equal to 10t. So x and y are in SI units. The acceleration of the particle at 2 seconds, a at 2 is equal to 1. So
A is given by ax square plus a y square under root. So implies ax is equal to d square x by dt square, that is equal to minus 4, and ay is equal to 0. So the acceleration at 2 seconds is given by minus 4 I cap. So acceleration is equal to minus 4 meter per second square.
179 is the question from electromagnetic induction. A long solenoid of diameter 0.1 meter has 2 into 10 power 4 turns per meter. At the center of the solenoid, a coil of 100 turns and radius 0.01 meter is placed with its axis coinciding with the solenoid axis. The current in the solenoid reduces at a constant rate to 0 ampere from 4 ampere in 0.05 seconds. If the resistance of the coil is 10 pi square ohm, the total charge flowing through the coil during this time is. So we know that the charge flowing del Q is equal to del phi by R, that is equal to del B into A by R, that is A into B is given by mu naught Ni by R. So here the current is changing. So mu naught N A is given by pi R square into change in current by R. So here the radius is 0.01 meter through which the flux is changing, and current I in the solenoid, that is reduces from 4 to 0, and the resistance of the coil is 10 pi square. Substituting the values we get as 32 microcoulomb. So the option is question number 180. This is a question from second law of thermodynamics. A Carnot engine having an efficiency of 1 by 10 as heat engine is used as a refrigerator. If the work done on the system is 10 joule, the amount of energy absorbed from the reservoir at lower temperatures. So we know that beta is equal to Q2 by W. Now beta is in terms of efficiency 1 minus eta by eta is equal to Q2 by W. Here efficiency is 1 by 10, so 1 minus 0.1 by 0.1, Q2 by work done on the system is 10 joules, so 10, so it will be 9, so Q2 is equal to 90 joules. So 90 joules has been absorbed from the reservoir at lower temperature, the first.